Morning, my dear students. In this video, I would like to give you a brief idea about the basics of engineering graphics. It covers introduction, drawing instruments, drawing sheet sizes, drawing board sizes, types of lines, lettering, and dimensioning. Engineering drawing is the language of engineers. The drawing may be artistic, but engineers use to draw the idea from his designs. These drawings are called engineering drawing. When an engineer designs a product, first he gives out a freehand sketch of his idea. Then he draws it according to the design, giving necessary dimensions, notations, production procedures, if any required. For that, certain rules have to be followed to make it clear for others as well. Engineering drawing is classified as civil engineering drawing, electrical engineering drawing, mechanical engineering drawing, etc. according to the specific branch of engineering. Civil engineers design and draw different buildings, bridges, etc. Whereas mechanical engineers design many machine parts and use machine drawing and production drawing by mechanical engineers. You should understand the different drawing instruments used by engineers. It shows a drawing board. It is made of 4 softwood or wood strips. They are connected by 2 battens using screws. At one edge there is a piece of ebony wood known as the working edge. This is the back side of the drawing board. It is known as T-square, used by engineers. It is used to draw parallel horizontal lines. You simply understand its parts. The mutually perpendicular 2 parts are stalk and blade. This is the working edge. And the stalk and blade are connected by screws. There is a hole at one end which is used to hang it on the wall. Set squares. 2 types of set squares are there. One is 30-60 degree and the other is 45-45 degree. Set squares along with T-square is used in combination to draw different angles or different lines parallel to each other. By using the combination of these 2 set squares, we can draw lines of 15 degree and its combinations easily. A protractor is used by engineers to take angles. It is how engineers use the T-square and protractor together. It is slided over this T-square and we can draw parallel lines. These are drawn 45 degree without any measurement because it is a 45 degree set square. Or other direction also we can draw 45 degree easily. We can draw a line here and a parallel line here by sliding it over here. In similar way, 30 and 60 degree can be easily drawn using the set square along with a t-square. Engineers use a drafting machine in an industry. It is called a mini drafter. It is a small form of the drafting machine which is used to draw in classrooms. A typical drawing board is shown here. The mini drafter is fitted around in the top end corner, top left corner. Here is a screw. We can tilt the 90 degree scale to any direction and draw any angle parallel at this corner to this corner. Instrument box. It contains a set of 13 items. The most important: a large compass. It is used to draw arc or circles of radius 25 millimeter and above. The small bow compass is used to draw circles of radius up to 25 millimeter. Large compass can be extended by lengthening bar, and we can draw circles of larger radius. Similarly, large divider and small divider to measure any distances on the drawing. Drawing pencil is another important item. It is dating from 9H to 7B. The 9H is the hardest while the 7B is the softest. For our classworks, we require HB and H pencils only. Wood pencils and mechanical clutch pencils with grading H and HB can be used for our classwork. Usually its shape is hexagonal in cross section. It is for better grip. Other items are sharpeners, eraser, flexible curve, stencil, etc. The point shapes of wood pencil, sometimes it may be cylindrical, may be conical, or chisel end, or bevel shaped according to our use. The flexible curves are used for drawing smooth curves, and the stencils are used for drawing shapes without dimensions. These are used for sketching only, not for drawing. This table shows the recommended standard scales for drawing. The full size, or 1:1, is the same scale we are all using now. In addition to this, reduction scales and enlargement scales are used. Usually engineers use a set of 8 scales named M1, M2, etc. up to M8. We can take dimensions directly from it. The scales are used for taking measurements only. For drawing lines, we use the set square or mini draft. It shows the designation of drawing boards to be used with the drawing sheets. Drawing board sizes are designated as D0, D1, D2 or D3. The paper sizes for this is A0, A1, A2 and A3. The drawing sheet sizes are designated as A0, A1, A2, A3 and A4. Usually for classworks, A2 size drawing sheets are used. All of you know the size of A4. For A4 is equal to 210 by 297 millimeter. That is 210 in width in this direction and 297 in this direction. That is our usual A4 size paper. And A3 is double of it. So you can easily see that 297 comes here and 210 is double here, 420. A2 is the double size of A3. That is 420 comes here and 594 is double of 297. Similarly, A1 double of this. Here a 1 millimeter is added. 420 double in the 841. And A0 is double of A1. Actually, this is 1 meter square size A0. So usually in drawing classes, A2 size sheets of dimension 420 by 594 is used. Here the dimensions are reversed. That is 210 by 297. Dimension is reversed. Width is named as 297 and the length is 210. Usually drawing sheet will be placed in this direction. Length along the horizontal direction. That is why the designation is, or the sizes are reversed. It is same as the above, the formerly mentioned sheet size, same. It shows the drawing sheet with the grids. Usually a 20 millimeter margin on the left side and 10 millimeter on all other sides are given. Here this margin is given for filing the paper. It is a paper with grid lines are given for easy work in the classrooms. This is title block for class drawing sheets. You just understand all these things. You need to study this, but understand. In our classworks, we use only A4 size sheets. We are not using any min drafter in the classroom for KTU syllabus. Okay. This is the working on a drawing board. It's a drafting machine. It is used to draw parallel lines in this direction. The vertical lines can be drawn using this scale. That is how an engineer works in a classroom. And types of lines. You have to understand the different types of lines. continuous thick line, type A line. All the visible outlines of an object are drawn on thick lines. Continuous thin lines, imaginary line, dimension line, projection line, header lines, hatching lines, etc. are drawn continuous thin lines. Continuous thin freehand lines. For interrupted views and sections, we use this type of lines. Long break lines are drawn by continuous thin zigzag lines, type D line. Dashed thick line for hidden outlines, hidden edges, etc. Dashed thin line for the same purpose, hidden outlines and hidden edges. Chain thin line. Center lines, lines of symmetry and trajectories are marked using chain thin line. For cutting planes, chain thin, thick ends are drawn. Type J line, chain thick line. Chain thin double dash line, special purpose lines, outlines of adjacent parts, etc. So there is a table showing type A to K lines. Termination of leader lines, so arrowhead, different types. It is a closed end type, closed but blank type, a tick at the ends, a dot at its end, and dimension leader or dimension line. Different arrowheads. Sometimes origin can be indicated by marking an O at the end. Usually it is drawn at 15 degree, open, closed type, closed and filled type. Different arrowheads are used. And thickness of lines. The standard thickness of lines is starting from 0.18 to 2 millimeter for drawing sheets. This is root 2 times, or 0.18 into root 2 is 0.25, and 0.25 into root 2 is 0.35. Or in other ways, we can say this is the double of this. 0.5 is the double of 0.25. 0.7 is double of 0.35, and so on. For drawing an object, the basic principle is the thick line and thin line. In this case, 0.7 is used for thick line and 0.35 for thin line. So thick to thin is half size, or thin to thick is double size. If you are using 1 millimeter thickness for thin lines, the thick line should be 2 millimeter. There is a rule. In our classwork, we try to follow this rule, 0.35 for thin line and 0.7 for thick lines. You can easily get mechanical clutch pencils of 0.3 millimeter from the market and 0.7 millimeter mechanical clutch pencil from the market. 0.5 pencil is also available, but for a better drawing, it is better to purchase a 0.35 millimeter or 0.3 millimeter pencil and 0.7 millimeter. This is a typical production drawing showing dimensions, type of operation, tolerances, etc. It shows different notations, different dimensions, different types of lines. These are thick lines, while these are thin lines. Just understand this. This is a production drawing. It shows a space shuttle with its carrier rockets. As we know, it is designed by human beings and it consists of more than 1 lakh parts. And of course, these 1 lakh parts consist of more than 3 lakh drawings. So that is the importance of drawing or machine drawing or engineering drawing. Another important factor is lettering. Its main features are legibility, uniformity, rapidity of execution, suitability for reproduction or Xerox printing, etc. The size of letter is 2.5, 3.5, 5, 7, 10, 14 and 20 in a drawing sheet. It shows the 2 types of letters. For D is the thickness of the letter and H is the height of the letter. And D by H is 1 by 10, 1 by 8 and 1 by 14 is also there. The letters marked on a graph sheet. Type A letter or D by H is equal to 1 by 14. That may be vertical or inclined. Inclined means inclined 14 degree from the vertical towards right. Type B letters D by H is equal to 1 by 10. That is also vertical and inclined. D is the thickness of line of a letter and H height of the capital letter. Where D by H is equal to 1 by 10, or its thickness is 1 and its height is 10. That is why it is D by 10 equal to, D by H is equal to 1 by 10. Sure. This shows the stroke for obtaining clear letters. For A, first, second and third stroke. For B, first, second, third, fourth and fifth and so on. Dimensioning. Different types of lines, projection line, dimension line, leader line, termination, origin indication, etc. A machine part is shown. These are the projection lines. This is the dimension. This is a leader line projected outwards. This is termination or arrowhead. This is origin indication, O. And value will be written here. All these lines are thin lines, except the visible edges. The visible edges are thick lines. Different arrangements of dimensioning. There are 5 types of arrangements. One is chain dimensioning, in which dimensions are arranged in a chain. Parallel dimensioning, superimposed running, where an origin is indicated and the dimensions are written at the end of the arrowhead. Another method, either it can be read in the right hand side or from the bottom hand side of the drawing. Superimposed running. Here the origin is indicated and the dimension is marked in the x direction. Here the dimensions are marked in the y direction in 2 axes. Dimensioning by coordinates. Here the point 1, 2, 3 and 4. Point 1 represents x, y, x 10, y 20. Point 2 represents 70, 25 and so on. So dimensioning by coordinates. Combined dimensioning. Is a combination of chain and parallel dimensioning. Usually most engineers follow this dimensioning method, combined dimensioning. And methods of indicating dimensions. There are 2 methods. Method 1 and method 2. In method 1, all the dimensions are marked. Either it can be read in the bottom hand side or right hand side. But in method 2, all the dimensions are marked to be read in the bottom hand side of the drawing only. And never mix these 2 methods in a drawing. That is the thumb rule of indicating dimensions. Bureau of Indian Standards. International System of Units and SI units. Now all over the world there is a system or internationally accepted system for marking dimensions or drawing, etc. In India, the Bureau of Indian Standards recommended many standards for different purposes. For drawing instruments, an IS 1444 1963 bar 1977 is the code, IS code. And so on. There are many IS codes are there recommended by Bureau of Indian Standards. Bureau of Indian Standard recommended to follow first angle projection only in India. That we will study later. But in European countries, they follow third angle projection method. So let us stop here. Thank you for watching.